The topics of discussion in this video are as follows. The statistical process, summary, source of data, storing structured data, connection between backend databases and front-end software, Python and R, data processing after connection, types of statistical analysis, data dissemination. The statistical process. The statistical process generally involves the following stages. Identification of data requirements based on the problem to be addressed or the decisions to be made. Selection of appropriate data sources. Evaluation of the quality of raw data. Data cleaning to remove errors and inconsistencies. Data transformation and processing to convert raw data into a structured form suitable for statistical analysis and dissemination. Statistical analysis. Dissemination of results through dashboards, research reports, and data portals. Data plays an important part in today's world. Sources of data are surveys, both census and sampling, geospatial data, contents on social media, administrative data published by government departments, private sector data, etc. Source can be both primary and secondary. Inference from several household surveys, both periodic and ad hoc surveys pertaining to sectors like education, health, industries are used by government agencies for effective policy formulation and evaluation. The indicators or parameters estimated are used to assess the performance in these sectors. It is important that the results are reliable. Storing structured data. Relational Database Management System RDBMS. A relational database management system RDBMS is a type of database management system DBMS that stores data in a structured format using rows and columns. It uses a relational model, meaning that data is stored in tables, also called relations, and the relationships between different tables are established using keys like primary keys and foreign keys. Examples of RDBMS software: MySQL, PostgreSQL, Oracle Database, Microsoft SQL Server. Language used in RDBMS. The primary language used to store, retrieve, and process data in an RDBMS is SQL, Structured Query Language. Having knowledge of relational databases and SQL is indeed beneficial for a statistician, especially if they are aiming for a job in the software sector. Connection between backend databases and front-end software. Example, Python and R. A connection is established between a backend database and front-end software such as Python or R so that data stored in the database can be accessed, processed, and analyzed without manually exporting files. How the connection is established? The connection is created using database drivers or connectors. These act as a bridge between the database and the front-end software. To establish a connection, the following information is required: database type, MySQL, PostgreSQL, Oracle, etc. server or host name, database name, username and password, port number if required. Data processing after connection. This is the phase where raw data is transformed for making data valid for statistical analysis and dissemination. Once the connection is active, two processing methods are possible. Processing while data remains in the backend. SQL queries are executed from Python or R. Only summarized or filtered results are returned. Data stays in the database. Next is processing after importing data into front end. Data is retrieved from the database, stored in Python data frame or R data frame. Analysis and modeling are performed in the front end. Statistical analysis. Types of statistical analysis. Exploratory data analysis, descriptive analysis, inferential statistical analysis, prescriptive analysis, predictive analysis, causal and mechanistic analysis. Exploratory data analysis, EDA, used to understand data structure, patterns, outliers, and relationships. Uses graphs, summary statistics, and data visualization. Descriptive analysis summarizes data using measures like mean, median, variance, percentages, tables, and charts. Inferential statistical analysis uses sample data to make conclusion about a population. Includes estimation, hypothesis testing, confidence intervals. Predictive analysis uses statistical and machine learning models to predict future outcomes. Includes regression, time series, classification models. Prescriptive analysis suggests actions based on predictive results, often combines statistics, optimization, and decision theory. Causal and mechanistic analysis focuses on cause-effect relationships, includes causal inference, experiments, structural models. Data dissemination. Finally, the results are disseminated through dashboards, research reports, and data portals.